Hello everyone, and welcome back to another remote sensing lecture video. And in this lecture video, I want to continue our discussion on errors with remote sensing data. In the previous module, we wrapped up talking about sensor error, and we basically said that sensor error are errors caused by malfunctions in the sensor. Right? Whether it was just a pixel that wasn't recording properly, or maybe it was as extreme as the example we went through with the scanline corrector where you have giant swaths across the image of no data. Right? But there's something about that sensor that is making the radiometric values incorrect. And we could either do nothing about it, we could figure out some way to do maybe an average or some sort of algorithm to fix it, or we could simply just ignore any new data coming from that sensor. In today's video, what I want to do is I want to talk about this idea of terrain or topographic induced errors. Let's go ahead and give ourselves a little space here. All right, I want to talk about terrain, or sometimes you hear it called topographic errors. And so what I want to do is I want to go back to the diagrams that we've been drawing since really the beginning of the semester. And that's this idea that we have some sort of Earth surface here. We have a sensor that's detecting the radiation. And then we have the sun that's, right, the sun's emitting radiation. And that radiation's hitting the sensor. Right? This is sort of the very basic diagram that we talked about the entire semester. But something that we sort of glossed over was what's actually happening here at the Earth's surface, right? We talked about atmosphere, and we're going to get back to that in a little bit. But we really have just sort of been dealing with this Earth surface here as really being just flat and almost like a mirror, right? That anything that hit it was going to exit it perfectly, right? We never really stopped to talk about, well, what happens here, right? What can we do here that might affect what we sense here beyond just the idea of absorption, reflection, and transmission? And so what I want to talk about is the idea that terrain and topography can actually impact the value. And so what I want you to think about is imagine for a second that instead of it being a flat surface like that, it is actually an inclined surface like that, right? So we have our sun and we have our sensor as best as I can draw them, right? They're in the same relative position, right? The sun and the sensor, right? These two things haven't changed at all. But what has changed is the angle of the surface of the Earth, right? This angle of the surface of the Earth, right? It's no longer flat. Now it's at some angle. And you can imagine now if we draw the same three beams of light, I'm going to try and be a little more careful here, right? If we draw the same three beams of light coming out of the sun, right? This is an oversimplification, but this is the general idea here, right? Is that when we had this perfectly flat surface acting like a mirror, right, that all three beams of light came off the sun and bounced back and hit the sensor. Right, now that we've changed the angle of the Earth here, right, we've got a mountain or a hillside or something, right? There's some sort of change in terrain and topography. Right, now what happens is maybe, right, a different proportion, I'm drawing this terribly here, but right, you can see in this example, all three of them hit the sensor, which means this was going to record more radiance. Right, this is going to record less radiance, not because the irradiance was any different or because what was actually on the Earth's surface was any different. It's just now the angle, right? The angular relationship, right? We call that the geometry, right? We call this, there's So let's use red. Right, we call this the geometry. Right, the geometry is now different between this and this. So even if this was, say, a leaf, and this was, say, a leaf, right, the fact that this is now on a slope compared to this being flat has now changed the angles with which the light is bouncing off, which is going to change the way and the amount of radiation that the sensor receives. Right, so even though it's emitting the same amount, it's in the same place relative to the sensor, simply changing the angle of the Earth's surface here is causing less radiation to be reflected in a direction that hits the sensor. Right, so let's take a step back and let's formalize this for a second. Right, so what we've done is we've changed the slope / angle of the Earth's surface right, we've changed the angle / slope of the Earth's surface relative to the sensor and the sun, right? The sensor and the sun are in the same position between these two. We've just simply changed the slope of the Earth's surface. And what that's done is that's actually changed, right? We've also then changed the amount of radiation that reaches the sensor. Okay? I want to recap that. All we've done between this one and this one is changed the geometry, right? The geometry between the sun, the surface, and the sensor, right? We've changed that geometry by changing the slope of the Earth's surface. And in doing so, we've changed the amount of radiation that is on a path that will reach the sensor. Okay? I want to repeat that again. What we've done is we've changed the geometry by changing the angle or the slope of the Earth's surface relative to the sun and the sensor. And in doing that, we've changed the amount of radiation that's on a path that would reach the sensor. Okay? This difference between this assumption and this assumption, that is topographic radiometric errors. Right? The idea that we can change the slope, and in doing so, we change the way the light reflects, and we change how much of that light being reflected reaches the sensor, as you can see in this sort of crudely drawn diagram here, right? By changing the slope, right now some of the light is being reflected in a way that the sensor never sees. So hopefully that makes sense. I know this one's a little bit more complicated. I know this diagram might be overly simplistic, but hopefully you get the core concept here, that we've changed the way the light is reflecting by changing the angle of the Earth. So now the sensor is seeing less radiation, or maybe it's more radiation depending on the particular angles involved. Right, we're changing away from this idea of a flat mirrored surface. Hopefully this makes sense. And as always, if you have any questions, please reach out. Thank you.